will see. Now, if you're not an IB, it depends on what test you're getting. Now, I assume that you guys will not be getting a formula sheet, but in the actual IB exams, you will be getting a formula sheet. So it honestly depends on what you're trying to prepare for. But in this case, I would highly advise to like try to learn those formulas, try to get them by heart, and do that whether you're IB or not IB. Now, moving into actual formulas themselves. Now, something that is very much so important is actually is understanding when to use each variation. Now, let's start off with sine rule. Now here it says for finding sides and for finding angles. And this is where there's these two flips. If you're finding sides, then you always keep the side on top and then do over sine A on the bottom, which is essentially just the angle. So you want to take the sine of the angle and over, or the other way around, on the side. So for instance, let's say I have a triangle and it's like A, B, C. Let's say A, and then it's A, B, C like that. Let's say that the angle A, I might have done this a little bit wrong. It would most likely look like this. There you go. That's how it would look like. You'd have your angles on the bottom and then your sides on top for when you're solving for the sides. Now, in case you're solving for the angles, which is another very common scenario, you would put the angle on top and the side on the bottom. And I'll show you guys examples of this later, but that's essentially what you do here. Now, cosine rule, I can't really say much about this besides just memorizing how it flows by doing practice, of course. Now, what you need to understand here is that a squared, which is our side, let's just draw a triangle real quick. This one is only used in a side configuration, which means when you're given this, so let's say you're given 6 here, you're given angle here as like 30, and then you're given like a side here as like 8, that is when you can use it. When there's this angle that's sandwiched between these two sides over here, that's the only time where you should be using this variation of cosine rule, because in other cases, then that means that there's probably a better way of using it, which in this case is either sine law. Now, I think it's really good to mention at this point that these cannot be used, or they can be used, but it's much more efficient to use these when it's not a right angle triangle. And that's because it's pretty much the only way you solve it. But if it is a right angle triangle, then you should resort to SOHCAHTOA. So try to understand when to use these different scenarios. For example, this is when you use cosine rule. Now, here, this is when another formula that you should memorize, of course. The angle this time is equal to b squared plus c squared minus a squared over 2bc. And that is when you have something like this, a side configuration, 6, 7, 8, 9. That's the times when you use them. Now, the way you kind of want to memorize these, and for the sine rule specifically, how they might look, it's mainly going to look like this. This is for sine rule. It's going to have something like that, a 6, and then you're going to have, let's say, another side on the opposite of this angle. Sorry, so it's like 6 degrees. Then you're going to have like something like 70 there, and you're going to have something like 8 degrees. So this is going to be like, 8. This is going to be side angle. So this is when you can use it, and that's pretty much the main scenarios of sine law. When you have an angle and a side that are like opposite, and you have this alone thing where you can solve for something like here. So, I think without further ado, for cosine rule, in case you don't really want, like if it's too hard to memorize, just remember that it's essentially this angle you're solving for is just these two sides, the side you're solving for is just the other two sides squared minus 2 times those sides multiplied times the cos of this angle. So that's pretty much how I want to memorize that. And for this one, it's really just the same thing, but it's kind of more difficult. So cos of A, let's say this is A. You would want to get b squared plus c squared. So that's b plus this minus this squared all over 2 times this and this. It's basically just memorizing and practicing. So moving on to our very first problem, and this is something that you guys want to try to identify. So before you do it, I want you guys to understand, we're solving for x. So how exactly do we go about this? Do we use SOHCAHTOA? Do we use sine law? Do we use cosine law? What formula do we use? I would highly advise to have this formula sheet like in front of you for now, but as you go on, try to like understand what's happening. But anyways, here, in case you haven't noticed, this is where this angle is being sandwiched between these two sides. So it is cosine law, and we solve for this. So the way we do this is applying that formula, which is going to be x squared over there is going to equal to 4.8 squared plus 6.4 squared minus 2 times 4.8 times 6.4 of cos of the angle, which is 1, 2, 3. Now, if you use a calculator, you should get the x, you should get it equal to about 97.46, and with proper notation, you would have to have the dots, and then you could square them out, because it's x squared, so it's x equal to square root 97.46 ... Now in this case, you don't really have to show it, but I would highly recommend to show this step. And anyways, that should be your answer after you square that. You do not do a plus or minus. The reason why is because this angle can only ever be positive, or like the side can only ever be positive, and you eventually get 9.8723 ... and then you get 8 equals, once you round it, 9.87 centimeters. And that is your answer. Now, this might be a little bit confusing, but I highly advise you guys to stick around and keep going. So here, there's another one, and we can see a kind of a different configuration. The first thing we can see is that this is angle, side. We have two angles, so if we look at our sine law, we're solving for sides first of all, so we'll put the sides on top, x, and we also have another side, so it's going to be equal to 10.2. That's going to be over, so our sides are on top, x over sine 28. And we also have 10.2 over sine 134. Now the reason why this works in this case is because we've identified that we're solving for the side. So we put the side on the numerator and put the angles on the denominator. And that's essentially how we set this up. I think it's not obvious with the equal sign right there, but there we go. From here, we can isolate for x by multiplying both sides by sine 28. This gets us x equals 10.2 sine 28. These are like under multiplication over sine 134. From here, this gets us, I believe, 6.65695 with the dots, and from there we can round it up to x equals 6.66 centimeters. So you basically just evaluate that with trigonometric functions in your calculator. And that is our answer. Now, moving on to our next example. And this one is pretty much the exact same thing. We might have noticed is that another approach of doing these types of problems is that you can actually get this angle right here. And we'll call that theta. That is our angle. Now, in order to solve theta, what we can do is take 180, which is the sum of the angles of a triangle, and subtract them by these two to get this. Now, that's probably a concept you guys are pretty familiar with. But basically, theta is going to be equal to 180 minus 73 minus 26. And from here, this should get you, I believe, 81. So once you've gotten that, we know theta is equal to 81, which is this right here, this thing. So what we can do now is pretty much try to solve, which is doing that x over sine 26 is equal to 13.5 over sine 81, which is our theta. Same approach as earlier, x equals 13.5. We multiply that by sine 26 all over sine 81. From here, we get x equals 5.99177 repeated, or x equals 5.99 meters. Now, from here, we can go down to 4. And this problem is another pretty unique problem. Well, not really. It's just the exact same thing being applied over and over again. Except actually, we have something a little bit more interesting that's occurring here. And that is the inverse sine function. Now, how do I know this? Well, the reason why is because we're solving for an angle. And anytime we're solving for an angle, that automatically makes us think, okay, how are we going to do that? Well, that's going to be doing inverse. So, we could do sine of x over 6.7 is going to equal to sine of 97 over 8.1. From here, we can just set sine x equal to 6.7 times sine 97 over 8.1, which gets us 0.82099 repeated, or from here we could take the inverse sine of both sides, so x equals sine of inverse of 0.82099, which is going to equal us to 55.2 degrees, and that is our answer. Now it's the same thing being reapplied, except we do this inverse sine mainly because we're solving for the angle, as I said earlier. Now here's another, a little bit more unique of a question. And this one is a word problem. And here, we kind of have to understand we have to kind of like draw the diagram first, and then we can continue on with the question. So, let's draw that out. 4, 6, 8. I'll draw it out in blue. So we could do it like that. Something like this. That's like a rough sketch, please keep in mind. But it's asking us to give our answer to one decimal place. This is going to be 4 centimeters. This one's going to be 6 centimeters. This one's going to be 8 centimeters. And it's asking us to calculate the size of the largest angle. Now, a very fundamental property of these triangles is that the largest angle is opposite of the largest side. So in this case, our largest side is 8. So this right here is our angle, and we'll call that theta. Or you know what, to simplify it, we'll call it A. Now, let's just solve for A. And the way we do this is that we need to look back here. And remember what I said about this rule. This is when you have side, side, side triangle, and you don't have anything else. And that looks awfully similar to what we have here. So let's do that formula. Cos of A is going to equal us to 6 squared plus 4 squared, those two adjacent sides, minus 8 squared. And we're going to do all that over 2 times 6 times 4. From here, it gets us cos of A is equal to, surprisingly, a kind of normal number, which is negative 0.25. Then A is equal to cos. We have to take the inverse, of course. And then that should be 104.477 after putting it into your calculator. And then you get 104.5 degrees. And that is our answer. That is rounded to decimal place. So if this didn't really make sense while I'm explaining it, that isn't really much of a problem. Although you should have probably gotten a grasp of what we're doing here in terms of solving for the angles and sides and like using these formulas. So I highly recommend doing the practice posted, and that should gauge your understanding a little bit better. If you need help, there's always the one-on-one server for us, and you can always support a ticket. So once again, thank you guys for watching this video, and keep on doing these problems, and you'll eventually get better.